Welcome to today's presentation, brought to you by Clayton Lamb. Before we begin, I'd like to share a land acknowledgement. The ABMI respectfully acknowledges that our work takes place on the territories of Treaties 6, 7, and 8, traditional and ancestral lands of First Nations and Métis people, whose histories, languages, and cultures are directly connected to the biodiversity that we monitor. We acknowledge the traditional teachings of the lands that we work on, and that reciprocal, meaningful, and respectful relationships with Indigenous peoples make our work possible. Clayton is a wildlife scientist at Biodiversity Pathways that has worked on a variety of projects across Western North America, including the recovery of the Klinze-za, I hope I pronounced that right, caribou, grizzly bear population dynamics in southeastern BC, and reducing wildlife vehicle collisions on the highways. Clayton lives in southeast BC near Cranbrook. So without further ado, I will pass things over to Clayton.
Thanks, Brett. Yeah, thanks everybody for joining in today. So what we want to talk about today is a recently published paper looking at the effectiveness of population-based recovery efforts for caribou. So just kind of set the stage of what we're going to talk about today. These population-based recovery efforts are those things that are directly addressing the sort of ecosystem and population-based decline. So these are wolves, feeding caribou, maternal penning. These are kind of these interim actions that are not necessarily habitat-based, but we'll get into the kind of distinction there. And there's a big group of folks that helped us bring this together, and they're highlighted here in the opening slide. And so this basically represents not everybody with caribou knowledge in Western North America by any means, but certainly a broad stroke at the provincial, federal biologists and the folks that have really been collecting a lot of the Western science data on these caribou over the last sort of 40 or 50 years. Okay, so this won't be news to anybody, but just to kind of set the stage here, we're talking about southern mountain caribou. So these are the caribou that inhabit the mountains of British Columbia and Alberta, and more specifically, sort of the areas south of Fort St. John and the Peace, really. And these caribou are a small population. They're largely fragmented into small little herds. And they have experienced dramatic declines over the last multiple decades, to the point that 15 herds have been functionally extirpated. So 15 of the 40. That means that they're basically down to less than 10 individuals. And 8 of those have been since 2000. So this is not sort of a historic problem. Like, these extirpations and the risks of these caribou are unfolding right now. I mean, the Selkirk population, the Purcell populations have been extirpated in the last decade, and as soon as one in 2018. So this is an extirpation and potential loss of a population of caribou within our lifetime. And 3 of those herds have been from national parks as well. So some of Canada's most highly protected and secure landscapes, we've lost caribou from there as well. So, really challenging situation. So, we, as scientists and as kind of technical experts, we always go back to the mechanisms and the theory and what is actually happening here before we start trying to do science and to implement interventions. We kind of want to understand what is the mechanism that is causing the declines. And so, kind of walk you through our kind of basic understanding of what the challenges are that caribou are facing. So, the biggest thing here is a landscape that is not working for caribou. So the current understanding, at least for southern mountain caribou, is that it's sort of a disturbance-based problem, and that disturbance comes from logging, from even damming landscapes, but logging, fire, and pests, like pine beetle and things that basically change old forests into no forest. And that brings in what we call early seral vegetation, or more simply, more young and leafy plants. So, you've probably all walked through these older forests that are nicely spaced and generally don't have a lot of forage, like shrubs on the ground floor. And when you cut down those forests, or when they burn, or when bugs kill them all, shrubs grow back. It looks like a clear cut or like an old burn, and there's leafy plants there. And that's not all bad news. I mean, it is for caribou, but those leafy plants bring in more moose and deer, and they bring in sometimes orders of magnitude more abundant moose and deer than the caribou that were there presently. And that's good if you're a hunter potentially, but it does bring in challenges for caribou. So what that brings in is more wolves, and those wolves are then numerically linked to the number of moose and deer, because those wolves prey on the moose and deer, and the more moose and deer, the more wolves, and vice versa. Theoretically, the fewer moose and deer, the fewer wolves. And what happens is these caribou that are living in that landscape are not necessarily that affected by the disturbance directly, but because there are more wolves, the wolves are running around hunting moose and deer, and they bump into caribou, and they predate on caribou at high rates to the point that it's basically unsustainable for caribou, and these caribou populations decline. There's a kind of an additional piece here where, through that disturbance of the landscape, primarily logging here in southern mountain caribou range, kind of changed the way that wolves use the landscape and how efficiently they can move across it. And so all these roads create a situation where wolves can actually move faster and further on the landscape. And so we kind of have this numerical piece where there's a large number of wolves, more than caribou historically would have coexisted with. And then those same wolves are actually moving in a way that essentially favors them and favors high predation rates. So again, a landscape that's not working for these caribou, and a predator-prey community that's not working for those caribou. And it all culminates in fewer caribou, and frankly, it has culminated in the complete loss of a number of caribou herds. The wolf predation is the number one mortality rate for a number of these herds. But there is this piece where it is obviously directly linked to the number of wolves and the number of moose as well. And so we sort of have this system that is a habitat-based problem that has moose and wolves in the middle, and deer as well, that is causing these issues. And of course, a habitat-based problem at the base, and one of too many leafy plants and linear features. And so, we'll get into the effects of wolf reductions and all of that, but the situation here is unique in that the caribou are not numerically linked to the wolves, and that creates a very unique situation. So, as say the moose decline, we expect the wolves to eventually decline, and so the wolves should never be able to drive a moose population to zero in kind of classical predator-prey thinking. But in this case, where the wolves are sort of bumped up by those moose and deer, the caribou can actually be driven right to zero by wolves. And that creates a very unique case where predation can actually have these major effects on wildlife, and vice versa, why some of these results are not necessarily applicable to why or how predator reductions would work on other species, but does have quite strong conservation implications for caribou. So, if the goal is self-sustaining populations, we have to address habitat. But in the meantime, we do have to do something for these caribou. And that's about keeping them on the landscape. So these forests, given that we're in a state where these landscapes have been pretty heavily disturbed, and we're talking about thousands or hundreds of thousands of hectares that have been logged and burned and dramatically changed, even if all those places were protected today, a number of these caribou herds would be lost still without something to do in the meantime. It will take decades to regrow those landscapes. And that's unfortunately the very difficult situation that we're in. So thinking about this population-based recovery, there's been a number of things that folks have tried. So they've tried to reduce the number of moose, which I tried to convince you that if you reduce moose, you should then reduce the number of wolves, and that should be good for caribou. folks have directly reduced the number of wolves, so that's usually sort of a culling type program. And they've tried doing maternal penning, where you keep caribou females safe in a high elevation enclosure during the breeding season, during the calving season, so they can have their calves in safety and grow their calves to usually about 6 weeks of age when they're very vulnerable to predation, and then release them where they're generally past that really vulnerable stage to increase calf survival. And translocations, where you're moving caribou from elsewhere if populations are, say, too low or genetically troubled, and those different treatments were basically all brought together by Rob Soroya and a number of folks in the paper on the left in the Proceeding of the National Academy of Science. And they want to know, like, how are these things working? Are they working for caribou, and what's the evidence of what's working better or worse? And they came to the conclusion that wolf reductions were, had positive effects on increasing caribou population growth, and that doing even more, like pairing wolf reductions and penning, was even more effective. And that actually created a bit of a controversy in that another group, on the right here, came back with a rebuttal paper that said, despite the statistical evidence on the left, they did a reanalysis and said that there was no statistical evidence for wolf control or maternal penning as conservation measures for endangered mountain caribou. So, this is, in some ways, this is how science is supposed to proceed. Like, folks go back and forth, but in this case, it does create a bit of a challenge in that we have dissenting views, we have a disagreement, and we have caribou sort of caught in the middle. So if those actions, if they're not working, for example, if the group on the right is correct, then we need to think about immediately how are we going to keep these caribou around, given that we need a stopgap while habitat is being worked on. And if the folks on the left are right, then how are governments to continue using those measures when there's a whole group of society that thinks that they don't work because of the information on the right? So how do we kind of move forward, and how do we provide the evidence to look after these caribou in the meantime? So that's kind of where we came in and wanted to know what, can we reanalyze some of these data? Can we provide some more evidence to sort of work through some of this controversy to provide some more information to understand what's working, what isn't working, and to guide sort of some of these future recovery efforts. And so, this is the distribution of southern mountain caribou. There's 40 herds, and this is their population growth rate before anything was done. So this is without any interventions. And the first thing I draw your attention to is the purple means that they're declining. Yellow is stable, and that kind of greenish color is increasing. And red is functional extirpation, which means those herds are basically gone. And I hope this convinces you that caribou were and are in a really bad state. I mean, I live in the southeast corner of that plot, and we are talking about the complete loss of caribou from hundreds of kilometers of range contraction from the south. Like, essentially the entire Kootenay region is on the verge of losing a good chunk of their caribou herds, and the rest are declining quite rapidly. And we are talking about a major loss of caribou here. So what was done to halt some of those declines were a variety of things, which I've mentioned, and in the brackets are the number of herds that this was applied to. So 22 herds have received wolf reductions, 5 moose reductions, 3 maternal penning, 1 has been fed, and 2 have got wolf sterilizations. And I think the goal was to ask, given that we're doing these measures, and given that some of them are incredibly controversial and frankly heavy-handed, like wolf reductions or dramatically reducing the number of moose or moving caribou from another herd, it's incumbent on the folks implementing these things to know if they're working. And that was sort of where we came in. And so, looking at all those caribou herds, there's been actually a tremendous amount of data collected on these caribou. I mean, honestly, unlike any other system I've ever worked in, you can, it's very rare to have a multi-province and, hundreds of thousands of square kilometers of really good population level data. So we're talking about 500 herd years of population estimates. So that's, every time a biologist goes and flies an annual survey on a herd, that's one herd year. And that might take the biologist a couple days and, $50,000. And so there's been 500 of those, nearly 600 recruitment estimates. So flying around and counting how many calves there are, 556 herd years of survival estimates. And those survival estimates are built off of 4,200 animal years of survival estimates. So that is, thousands of collared caribou all across these landscapes, monitoring survival, monitoring cause of death. So really, really good data. In some ways, for a lot of it, it was just monitoring these populations, they declined, which is not always that encouraging, probably to the biologists, nor to the scientists that are supporting them. But now, after some of these interventions have been implemented, those same data can tell us how those, fairly, unfortunately, precise declines, whether those have changed at all. So we used an integrated population model, which is, on the back end is a fairly sophisticated and complicated Bayesian population model, if you know anything about statistics. But in sort of simple terms, it is basically a way to use all kinds of different data in the most efficient way possible to sort of get the most use out of different ways of looking at population and to bring it all together and get an integrated inference. And by doing that, we can actually do cool things like this plot, which is an estimate of the entire population of southern mountain caribou between 1991 and 2023. And this it tells a lot. It's sort of one of those, like, a picture says 1,000 words, and it tells us that it paints a bleak story in some ways, in that in 1990 there was nearly 10,000 caribou in British Columbia and Alberta in the southern mountain caribou population, and by around 2013, that population of 10,000 had declined to about 4,000 animals, which is an absolutely dramatic decline of a large mammal that is threatened status and is on species at risk list. But if we kind of zoom in to that further right side, what is a bit uncharacteristic of those declines and of a threatened species is a fairly strong rebound in recent times, which is the recovery or the increase of about 1,500 caribou today compared to if things had kind of gone as normal post 2013. And so, we're talking about 50% more caribou on the landscape today than otherwise would have been without folks trying to do something for these caribou. So, that is a good news story in this. You can see that where we're at today, the projections go to 2023, is still only a fraction of what was there in 1990, and that is likely a fraction of what was historically here. So it's not as if this small blip is all that caribou need. They need a lot more. But I think at a minimum, seeing them turn around is very good news, and seeing this at a population level is quite encouraging. Okay, so some of the results of the model is that we can start to ask, how have each of these individual treatments or recovery actions helped caribou, and what is their population growth rate as a result? So I'm going to kind of walk you through this plot. On the y-axis, sort of all that text are the different things that were tried for caribou, and they are, like I said, penning and wolf reductions and moose reductions, and then all different versions of them that were applied in combination or on their own to all these different herds. And the second from the bottom is the reference, which is doing nothing. That's kind of the status quo, nothing being done, just sort of watching the declines. And in the middle there, you'll see a dashed line, and anything to the left of that line means that the population was declining, and anything on the line means it was stable, and anything to the right means it was increasing. So, being on the line is okay. It means you can kind of stay small or stay as you are. Being right of the line is really good. Being left is you're declining down to 0. So this is sort of what we see. I like to build the suspense. Hold on, my arrow's not working. There we go. Okay, so this is the reference. So this is sort of the situation where these herds were unequivocally declining to zero with nothing being done, which I think everybody understands, given that 15 of the 40 were wiped out. And this is a situation with the different treatments. So in general, the populations are increasing, except for maybe with moose reductions, but otherwise, there's pretty strong evidence that most of these things are working. They're working to varying degrees, though. So the distribution of those little they're normal distributions, but little blips or whatever you want to call them, it indicates the degree of certainty. So if it's really, really narrow, like the yellow one at the reference, we have a ton of certainty about the response. It's all to the left. Whereas, like, feeding, there was only feeding for one herd for 1 year. And that makes the model is then very, very uncertain. And it's the median is to the right. So the model is kind of like, yeah, this probably works, but I wouldn't bet my life on it. Like there's a lot of uncertainty. And it varies up and down from there. So in general, most of them are to the right. So that's pretty good news. Things are working. Potentially a stronger test is a before and after comparison, because you could imagine, what if folks just cherry picked these herds, and the ones that were increasing, they put wolf control or wolf reductions on, and they kept increasing, and then all of the wolf reduction herds had an increasing signature, which would not be a very fair thing because you just selected the right one. So a stronger test is to compare how the intervention changes the trajectory of that herd compared to what it was doing before when nothing was done. So, if it was declining by 5% a year, and then you do something and it starts increasing at 5% a year, well, then you have a 10% increase or change in direction. And so that is a stronger test because it kind of controls for your selection bias. And that's what this plot shows you. So this is kind of the change in the instantaneous growth rate. And again, anything to the right is good. Anything on the line means that nothing's really happening, and anything to the left means it actually might be worse. And so this is kind of where we get into measuring the actual effect of the treatments. And so right at the top there, you can see penning and wolf reductions, pretty strong effect. That's largely driven by the Klinziza population, which is led by West Moberly and Soto First Nations. There's a new pen in the cusp, which is only a couple years old. It's not working as well. That's the line to the left, but only a couple years there. So that's why the distribution still pulls to the right, because that's way more data in Klinziza. Feeding, I explained, 1 herd 1 year. We don't know a lot about it on its own, but feeding and wolf reduction together, really positive growth. That's the Kennedy siding herd, just kind of east of Mackenzie, and growing really rapidly. Reducing moose and wolves, pretty good. And the one that folks are often most interested in, either for or against, is wolf reduction. So it's kind of in the middle there, and strong evidence of being right of the sort of it doesn't have an effect line, and being to the right means it's working, and pretty strong evidence that wolf reductions can turn those herds around. And then it kind of goes down from there, or smaller sample sizes and those kind of things. Because the model is fairly sophisticated, we can actually break out some different aspects on how mechanistically those treatments are impacting the actual vital rate. So population growth rate is obviously only driven by survival, more adult females being able to stay alive, and then being able to produce calves. So we can kind of decouple that and get an insight on what's actually creating those increasing populations. And one thing that's pretty consistent is that we get these bumps in adult female survival, which is not that surprising because that's the most sensitive parameter for these long-lived mammals. And so when we can bump up adult female survival, and then in the cases where we can do both, bump adult female survival and recruitment, we get these pretty positive growth rates. Trying to simplify it a little bit, because it does get a little confusing when it's this plus this or that plus that. It's like, what is the individual effect of each of these things by trying to decouple that in a model which basically says, are they all additive, which is not necessarily a perfect way to do it, but to sort of get some insight into what is likely working for these different herds, we can use that kind of simplistic case. And these are the distributions of the 5 different recovery actions. So again, it kind of aligns with what you would have seen before. This is the change in the values, so what we expect the intervention to do to the herd and change its trajectory. So wolf reduction really strongly to the right, penning also to the right, but a little more uncertain. Feeding, same deal, and then moose reduction, some evidence of it helping a bit, but not as strong as the other ones, and then not much evidence of wolf sterilization, which makes sense because we do know that you have to reduce the density of wolves quite dramatically, and in theory this could work, but it would have to be done quite intensely, and it might be logistically quite challenging. And when it was implemented, it probably wasn't implemented intensely enough. So those are all Bayesian posterior distributions, which I like as a scientist and as a technical expert, but if it helps, it might make more sense to look at these as a caribou herd, as a declining caribou herd. So this is basically what caribou were doing. This is at a herd level, in a lot of cases in kind of the 2000s, there was maybe 100 of them, and they rapidly declined to 30 or 10 of them or none by now. So this growth rate is actually what we observed for a lot of these herds through time. So this is the reference. There's a whole bunch of numbers to the right of there. Don't get too distracted by them, but they indicate the probability of an increase. So that's 0. There's no chance of an increase. What percent, what chance of going extirpated, so 27% chance, and then what the ending population size was, so about 16 to 30 from 100. And so this is the status quo. And then I'll throw out some lines here that are the possible outcome of that population at year 0, which is right in the middle, if you did the different interventions based on our best estimates. And you can see some interventions don't change the counterfactual very much, like wolf sterilization or moose reductions. They do about the same thing, but these different interventions, especially wolf reductions, maybe feeding, but lots of uncertainty, penning and wolf reductions, or feeding and wolf reductions, these can create actually really rapid growth in these caribou populations. So not only stabilizing them, but actually allowing quite rapid recovery of caribou. Again, these are in some ways those populations are being propped up or subsidized. Like, it's not a self-sustaining population, but regardless, we're talking about rapid growth potentially, which is obviously much better than the extirpation that herd was on a trajectory for. So what did we learn from all this? So on the ecological side, removing predators produces significant increases in caribou, and this is not a new insight, in that it confirms the importance of predators in the decline of caribou. I mean, there are decades of research of biologists following these caribou, unfortunately to their death, with radio collars, and finding out that predation was a main driver of mortality, and the mortality rates were unsustainable. So those two things, that the survival is too low to sustain the population, and what is causing that low survival is predators. So this is more confirmatory, and in some ways, like in an experimental sense, it confirms that, because when you reduce that predation pressure, those populations increase quite rapidly. Recovery actions that target pathways that are sort of further from caribou had a lesser impact. And if you think back to that those first slides showing the mechanisms, as we kind of went to moose reductions, for example, it starts to not work as well. And that happens for 2 reasons. One is moose are not the only prey in the system. So you could reduce moose quite dramatically, but if all of a sudden there's a bunch of deer or elk, the wolves can actually stay quite abundant, or they can disperse in, or there's other ways in which for every piece of effort put towards moose doesn't necessarily have a 1-to-1 reduction in the number of wolves. And, of course, directly reducing wolves had a more certain effect. there's something interesting about the feeding piece that I think needs a lot more replication and attention. There seems to be something positive, at least for one herd in one place, where feeding might be able to help these caribou a bit. But from a technical side, I'd say it's fairly uncertain at this point because it's not. It hasn't been replicated, and that herd is really a special case in that they come down right beside the highway. So it makes, in the fall, it makes it really feasible to feed them at the right time. It could be very challenging in other herds, but regardless, it's certainly something that warrants some more attention and some more replication. On the conservation side, what does this mean for caribou conservation and keeping caribou around? So we know for certain that without intervention, these caribou populations will be extirpated, and we have lots of evidence that will happen. Habitat protection and restoration is ultimately what these caribou need. Like, all of the authors here are it's unequivocally where folks stand. Like, everybody understands that habitat protection and restoration is what these caribou need. But in the meantime, they also are going to need something. Even if protected today, habitat protection and restoration will not save these caribou today. The goal is that it will in the future, but they will need a stopgap in the interim, or we will lose these caribou. And that at the moment are these population-based interventions. And at the moment, that is largely wolf reductions. And that is what we sort of show here is the most effective and consistent approach. But the door is also open if folks want to explore other options and find either more effective or solutions that don't involve reducing wolves. Like, I think everybody's keen to do another analysis like this and keep testing what's going to work in the meantime, and of course not let that distract us from putting our efforts towards the habitat restoration. So not get so caught up in the meantime that we lose the plot for the bigger goals here. And combining management actions results in faster growth. So if the provinces or indigenous nations that are leading wolf reductions, if those folks are going to reduce wolves, and we are talking on the order of hundreds and thousands of wolves, like these are severe reductions in a predator population. If you're going to do that by adding other management actions, so whether it's feeding or penning or different things, you can get a lot more sort of value out of those wolf reductions by layering additional actions on top. And those populations those caribou populations will actually grow quite rapidly. So maybe that is a way to get the most out of the time that folks are doing these heavy-handed interventions. There has long been a narrative, and it's not wrong, that the wolf reductions are this stopgap measure, and that the provinces and the governments might just shoot wolves forever and they'll never do anything meaningful about habitat. And that in some ways is not an unfair critique. I mean, the evidence supports that there hasn't been a lot of progress for caribou habitat at the range level. But I want to flag that, so folks don't feel despair about the situation, that there are examples where this the sort of plan of giving caribou some help in the meantime while these larger habitat discussions are ongoing, where that actually has unfolded as planned. And in the central group of Southern Mountain caribou and kind of in the Peace area of British Columbia, there's an example where in 2013, the Indigenous nations, two of them were Saulteaux First Nations and West Moberly First Nations, began a fairly aggressive and ambitious caribou recovery program, which was largely based on reducing the number of wolves and maternal penning. And through that, the nations actually have now quadrupled the abundance of those caribou, which is almost doing the impossible. At the time, it seemed like a feat that was not possible. But at the exact same time, they were working diligently with the province and with the federal government on securing an absolutely massive amount of habitat for these caribou. And in 2021, February of 2021, that agreement was signed. It's called the Caribou Partnership Agreement, and it covers nearly 8,000 square kilometers of habitat in the central group for caribou. And this is a significant contribution to caribou habitat. What it doesn't do is that, you know, the second that protection goes down, caribou habitat is not fixed, but it creates the conditions where habitat restoration can happen, and it's secure, where you're not, you know, replacing restoring one road in a valley and then, you know, one valley over, somebody else is building a new road, and every day those clear cuts that were there are growing in, and so the habitat is getting better by the day there. And so, you know, it is an example where at a landscape scale and at an ecotype level, there is some meaningful habitat protection and restoration going on. It is not enough at the population level, and, you know, to really get caribou habitat online, there'll be a lot more work needed. But just to give folks some sort of hope that there is examples of this actually working. And that's it. So yeah, thanks to the team and the group of folks that really made this happen. And yeah, thanks to you guys for listening, and I'm happy to take any questions.